I'm the sole person watching right now.
Wait, is there a way I can watch the stream too? Nah, probably not a good idea.
Yeah, you can watch it after we're done.
Yeah. Ooh, they can't hear me, right?
They can hear you.
Right now? Oh, okay.
Yeah, we're live.
Sweet. I guess I'll just mute my mic when you start talking.
Yeah, sure. All right, let's get started. Good morning and welcome to the Pubnub Hackalong live stream. My name is Adam Pavosa, and I'm a DevRel manager here at Pubnub. And today we're going to be creating an IoT device that uses the Pubnub network to publish tweets to a Twitter account. We're going to set up a Raspberry Pi 3 that has a push button, and when pressed, it will post a tweet to a Twitter account using Pubnub Functions. So we're going to get the walkthrough from Cameron Akhavan. The setup of the IoT device is going to be explained at a beginner level. So if you're curious about building fun setups with breadboards and pins and you haven't worked on anything before, you're in the right place. So today we're joined by former Pubnub intern Cameron Akhavan, who is an IoT enthusiast and undergraduate student at the University of Southern California. Cameron spent this past summer working at our San Francisco office on developer education content relating to blockchain with Pubnub and IoT with Pubnub. So before we get started with the IoT hackalong, I'm going to spend a few minutes talking about Pubnub. So what is Pubnub? Pubnub is the connector of all the world's devices so they can interact and communicate in real time. Software developers use our platform to build apps that need to connect, deliver, and control streams of data in real time. Pubnub makes this possible with 70 client device SDKs and the world's largest and most used data stream network. So if you're a software developer working with an internet-capable device, you can implement Pubnub for real-time data delivery. The best use cases for Pubnub are sending messages in any kind of chat application, for IoT device signaling from smart homes or agriculture devices or Raspberry Pis. And also real-time updates like device synchronization in multiplayer video games, triggering push notifications, triggering emails, triggering texts, or triggering tweets. Our network transfers twice as many messages per day than the entire global SMS system, which adds up to over 1 trillion messages every month. And at the moment, we have over 2,000 customers around the world and 330 million devices using Pubnub. Whether you're a hobbyist or an enterprise company, you can use Pubnub. Some of the popular use cases for Pubnub are multiplayer games, IoT and smart home, transportation and delivery, healthcare with HIPAA, live collaboration tools, and also audience participation. So next we're going to get started with the hackalong with Cameron, who is live from Los Angeles. What's up, Cameron?
Hey, hi. Thanks for the thorough introduction. So, hi guys. My name is Cameron Akhavan, and I'm an electrical engineer studying at the University of Southern California. And today, for the rest of the webinar, I'm going to show you guys how you can implement Pubnub into the world of IoT. So let me just share my screen really quick. Okay. There we go. Can you see me?
Yep, all good.
Sweet. Okay. All right. So as Adam explained, Pubnub is a very versatile tool. With its numerous APIs and simple-to-use PubSub infrastructure, Pubnub can be used to build a wide variety of apps and web services. However, one thing Pubnub does especially well is implementing IoT devices in projects. I mean, since it's so incredibly versatile and simple to use, Pubnub is the preferred choice for IoT hobbyists and specialists alike. In fact, it's so simple that you could quickly build really cool projects like making a tweet button, which is what's going to be the exemplar for today's webinar demonstration. I'm going to show you exactly, step by step, at a beginner's pace, how to, tweet anything you want, anywhere you want, with a push of a button. And actually, let me just show you really quick what that looks like. Let me just share my screen really fast. Okay. Can you see me?
Yes, we can.
All right. So this is the setup. It's got a Raspberry Pi working here and a little push button here. And I'm going to just push this button. And hopefully that registered. And now I'm going to share my screen. And let's go check my Twitter. Okay, and the tweet should have showed up. And let's see here. Well, okay, it doesn't seem like it's showing up because I think my program stopped running, but it's okay. This is what I guess it was supposed to look like because I'm running the Raspberry Pi off my phone hotspot, so I guess the internet connection cut out. But essentially, you can, tweet pretty much anything you want, and with the button, as long as the internet connection is established, you could tweet things like this. This is a little test case I did right before this webinar on October 4th. So yeah, I mean, I'll show you how to do this, but I'm not going to bother rerunning it just because it would take just a lot of irrelevant time, but that's okay. Before we get into, I guess, the logistics and specifics of how to build a Pubnub push button, let's first explain what is IoT. Well, IoT stands for the Internet of Things, and it's an umbrella term that encapsulates pretty much any piece of tech, whether software, digital, or hardware, that uses the internet as a medium for data transmissions and network connections. Examples of this could include, like, phone applications that could post real-time data of your, weather, local weather news channel, or, even little robotics, little smart lamps, smart cars, smart pretty much anything is coined the term. But all these things are related under just using the internet as a very specific medium because it's very fast and very well connected around the world. But one thing that is very symbolic of IoT, and it's probably the face of IoT, are what are called microcontrollers. On the right, you can see this little blue thing. It's called a mbed microcontroller. And this is actually specifically designed for IoT. It's got a bunch of little pins here and a little, circuit board and stuff like that. But the thing that microcontrollers really do is allow engineers or hobbyists to interface their software to these little pins. And I'll explain how that works later on in the webinar. But all we have to know here is that there are plenty of different microcontrollers that are out there. They come in all, shapes and sizes, and they all are intended for very certain or specific things, or very general things, which is a specific thing in itself. So on the mbed is very specific to IoT, but the drawback here, I mean, since it's low power, very cheap, and it's designed to run mainly IoT applications, it's a little more difficult to use, and it's actually very limited. It can't do a lot of things. Whereas for this webinar demonstration, we're going to be using the Raspberry Pi, which is a very general purpose and favorable among the market microcontroller. And the reason being is it has all these little ports here. It's got 4 USBs and HDMI, Ethernet. It's got so many different capabilities and all these different pins that are used to control different things. But it's very, versatile, but it's very general, and it's not very good at very specific tasks. But it's great for hobbyists. It's great for specialists. I mean, it's relatively cheap, and that's what we're going to be working with today. So if you have your Raspberry Pi, it's going to come out of the box with the Pi itself, the power cable, and the micro SD card. Now, the reason why we need the micro SD card is because it's not going to work straight out of the box. The Raspberry Pi is going to need what's called an operating system. Now, what is an operating system, Cameron? Well, is it like Linux? Is it like Windows, Mac OS? It's similar. Yeah, those are all OSs, but pretty much an OS could be anything. It doesn't have to be any of those. All an OS is pretty much a software user interface that allows the user to present the screen to himself in a way that he can talk to the computer's hardware components in a very simple way. It allows us to pretty much simplify the process of telling the computer, hey, get this little piece of memory from this chip, move it to this chip at this certain time, and do this in all these certain orders. It's too complicated for a normal human being to do, so we need an OS. And OSs are optimized for very certain things and very many different things, just like how microcontrollers are also specialized for many different things. The OS we're going to use for the Raspberry Pi is going to be called a Raspbian. And that is actually a very general purpose, very simple and user-friendly OS. And that's the reason why we're going to use it. But that's not what it's limited to. You can use pretty much any OS you want. But if you go on the Raspberry Pi Foundation's website, you can see the very simple to install instructions. You can download it on Mac, Windows, or Linux. But this is not the only OS you can use. You can also use what's called Riot OS, which is an operating system designed specifically for the Internet of Things. It is low power. It's very efficient for internet data transmission, but it's pretty much used specifically for it. So there are obviously millions of OSs out there, and open source like Riot. But you can pick and choose whatever you want. But we're going to stick to Raspbian today just because it's very simple to use. And anyway, so you would download the OS onto your micro SD card, which connects to your computer through this little adapter. And once you're done with that, take it out of the computer, and then you insert it at the bottom of your Pi, and then the Raspberry Pi should start running. Now, the next step would be setting up what's called Secure Shell Protocol, or SSH. And what SSH is it's a little protocol that allows users to remotely access their Raspberry Pi terminals from their computers anywhere in the world. And the benefits of that is that we don't have to have a cable to connect to our Raspberry Pi. We don't have to, take out the SD card, put a program in it. We don't have to do any of that. It actually simplifies the process of pushing code and developing code. And if we supplement it with GitHub, you can get this little process here, which is the main reason why many users use it in this way, is that you pretty much from your laptop, code it wherever you want, update it whenever you want. You'd push that code to what's called a cloud repository, or GitHub. You'd save your code there, all its iterations. Anytime you want to update your code, or your friends want to update your code, they would just keep pushing their code to this little repository you have in the cloud. And then you could use SSH wirelessly, get into your Raspberry Pi, and then from there, you could pull the code from GitHub. So this actually is a very smooth process. It pretty much simplifies and speeds everything up for developing apps and stuff. And it's pretty much the normative way of IoT development. So to enable SSH on your Raspberry Pi, you're going to need to go to this link right here. And it's essentially very simple to use. You just got to, let your Pi know with a little text file that it wants to enable SSH. Most Raspberry Pis like mine already come enabled. So once you do that, you need to go into your Pi and get its IP address. And what that looks like is just, go into your Pi terminal, type in sudo ifconfig, note the IP address, save it forever, keep it somewhere safe, and now you can get into your Pi with this simple command where it's just ssh pi at, and then the IP address. And of course, all this is on the Raspberry Pi's website if I'm going too fast, but it's as simple as that. And anytime you want to SSH into your Pi or go into your Raspberry Pi's terminal, just type in ssh pi at and the IP address. Now, GitHub, as I mentioned before, is the cloud repository coding service that not only allows us to easily transition our code from our computers to our Raspberry Pi, but also allows us to distribute code to the world. And for our case, we're going to actually be pulling code that is made from the world. So we're going to use this to get sensor libraries or install software. All this is going to be handled through GitHub, which makes code distribution and library distribution a very simple process. And it's just going to make installing code very easy. So with everything we're going to do in this project, it needs to be not only installed on your local computer, but also on your Raspberry Pi. Because again, these are two separate computers. And just because you're SSH'd does not mean they can communicate their different files and structures. So on your local computer, you're going to need to install GitHub. And the way you do that is, if you're on Mac, you install a little package manager, which you would type in this line into your terminal screen. And then this would install what's called Homebrew, which basically allows us to really easily install a bunch of files and applications. It's so easy that, to install GitHub, all you have to do is just do brew install Git, and then it'll handle every it'll sort every package for you. But they're, Windows equivalents and Linux equivalents. So just, I mean, for Linux and think Windows, and it's sudo apt get install. So, but for us, for Mac, it's what I'm coding on is brew install git. That'll take care of git on your laptop. And then from there, we're going to have to make a little directory for our project to save it in. So go into your terminal, and then you have to make a directory, pubnub, let's call it. Go into that directory, and then to initialize GitHub on your computer, you need to tell it where to start looking to push files from that are on your computer. So since we're saving files to this pubnub thing, that's where we're going to make our application for this little push button. We need to tell GitHub to initialize a repository once you're in the repository, add it, make a commit, and then you have to add the branch to your repository. So you do git remote add origin, and then the repository URL you made on github.com. And then do this last line, git push -u origin master, and then GitHub will now be looking into this specific folder to whenever you want to push or pull code. And this will be really simple, but it's even simpler actually on the Raspberry Pi, because all you need to do is just do a sudo apt get install git once you're SSH'd in, and you'd be good to go. That's all you need to do. Raspbian takes care of all the little idiosyncrasies of what we just did. So once you do that, you just get out of your Raspberry Pi, and now we can move on to the hardware. And this is, I think, the more interesting part, because there's no more setup involved really. But this is the schematic for the Raspberry Pi we're working with. So as you can see in the center, we have a CPU or GPU. And this is standard for pretty much any standard IoT devices. You need a computing system to process all the data you're going to put into it from the internet. And you're also going to need, it's going to have, an internet chip and all of these different ports, which make Raspberry Pi so popular. It has a USB port, an Ethernet jack, an audio jack, and all these different things. But the main thing we're going to be looking at are these little pins called GPIO pins. They're called general purpose input-output pins. And essentially, each of these pins corresponds to an input pin or an output pin. And they could be both, meaning you can tell this guy to be an input or an output. Hardware. You can use it to control a lamp or something like that, because all you do is just tell your program to turn it on. But if you want to use it as an input, like what we're going to use today for like a push button, it's going to say, I'm going to start reading in signals from this pin. Meaning if I push a button on the outside world, I'm going to know when that happened. So that's just basically the inner workings of Raspberry Pi. But you can actually Google Raspberry Pi pinout. But installing IoT devices is actually not as complicated as it looks. Pretty much the standard for any IoT device is it has 3 or 4 pins. It has usually a power, ground, and a data pin. In this case, for an ultrasonic sensor, it has a trigger and echo pin. But all you need to do for any IoT device is put it to a breadboard, which is a little prototype board, and connect it in such a way. But all you have to do really is not even worry about this. You just go on the website of, let's say, for this one, for example, the DHT11 temperature humidity sensor. All you have to do is just Google the schematic online, such as DHT11 Raspberry Pi schematic, and it'll show you exactly what pins to connect it to, which pins are the power. So for this one, power is here, you connect to a power there. Ground is here, connect to the ground there. And the data pin, which is what the information is coming in from the outside world, goes in here and goes into an input on the Raspberry Pi. But it's all simple. It's all online on the company's technical documentation. So if you want an ultrasonic sensor, temperature humidity sensor, that's all you have to do. LEDs are even more simple. Push button is what we're going to be doing today. So this is how you would actually set up a push button. This is exactly how mine is set up.
So this white thing here is the breadboard, and the little devices that go on there are LEDs, push buttons, and sensors. Right,
yeah. So let me actually explain what a breadboard is further before we move on. So a breadboard is actually a proto board, stands for prototype board. And basically all these rails you see on the sides, just this red line that goes across, and this blue row that goes across, and vice versa on this other side. these are connected lengthwise. So this pin, or this little hole in the top left corner, is connected to all these other pins all the way up to this top right one right here, and vice versa for this little bottom one. And these are used generally just to, you put in your like a power source into here and a ground source, and then it just makes, hooking up wires really easy. But we're not going to have to worry about that today. We're going to look more at these little horizontal pins, and same concept goes for these ones. Every row of 5 pins, or every column, I should say, from this perspective, is connected in series. So this hole is connected, this hole is connected, this hole all the way down, but it's not connected to the hole across. And this is really useful because now you can cascade different electronics, like this little push button here that we have connected in this column and this column. And a push button, all it is a switch, right? So if we connect a little ground pin here to one side and then have the other side of the switch connected to an input on the Raspberry Pi, we could just say whenever, the switch is not being pressed, don't allow electricity to flow through, and electricity will not receive our data pin, and our data pin will not get any information. But when the push button is pressed, you do allow the flow of electrons, and then the data signal or the electricity will flow through the input pin and tell our Raspberry Pi, hey, this pin is lit up. I'm going to start doing some stuff that you programming
signaling.
Exactly. So you could cascade systems very easily. I mean, as you can see, each individual IoT device is hooked up in a certain way, but it's no different when you want to cascade them as well. I mean, you could share the same grounds, like what I did here. You could share the same power pins with these whole, long vertical pin inputs, but it's a really clean process. And this is the whole idea of IoT, is you're just cascading different systems. Let's say you have a push button hooked up to this little sensor. You could say, hey, I want to turn the sensor on. Let's start taking little, temperature inputs when I press the button. And when it's taking inputs, let's just let me know and others know that we're taking inputs with turning on the LED. I mean, it's the whole idea of IoT is just building these little complex or simple circuits, just like this one shown, and just hooking up to your Raspberry Pi. And that's what makes Raspberry Pi so easy and, versatile to use, is that it has so many, input GPIO pins to allow you to do this in such a clean and easy manner. So, as we mentioned, once we've hooked up, a push button in such a manner, you are going to need a sensor library to interface your IoT sensor or push button. And just before we move on, it's important to note, because people always forget, when I work with children or work with professionals, people seem to always forget when they're debugging why their things don't work. Well, it's probably because they didn't install their libraries both on their computer when they coded the code and on the Raspberry Pi when they're trying to run the code. So everything we do here needs to be done on the laptop itself and in the Raspberry Pi. So, for example, the first library, the Raspberry Pi GPIO, or General Pin Input Output 0 library, is probably the most versatile and essential library of Raspberry Pi. It's a library that essentially makes installing push buttons, LEDs, or just simple, like let's turn this on or let's turn this off or let's treat this like a button. It's just a very versatile library that makes coding very simple things like LEDs or simple on-off switches very simple on the Raspberry Pi. So to install this, you actually only need to install this on your Raspberry Pi, because we're not going to be interfacing anything on our computers. So just SSH into your Raspberry Pi and you type in these commands: sudo apt update, all these things, install the GPIO 0 library, and it's as simple as that. I mean, with our the sudo apt get install package manager tool for the Raspberry Pi is going to take care of everything for you. So you just need to type in those commands. So, but for other specific sensors, so let's say you use this little temperature humidity sensor right here, it's not so simple to turn on and take data inputs. This circuitry in there is actually working in a very specific way. The data it's coming in is actually in terms of bits, which is ones and zeros. So it's going to be successive. It's not just going to be, oh, it's going to be turning on. It's going to actually be turning on and off at a certain frequency that's going to correspond to like a number in real life. So it's going to like turn on and off 5 times in 5 seconds. And that's going to stand for like 22, for example. But the point is, it's very difficult to code these things, and that's why you need a library to get them. So to get these libraries to actually use the sensor itself, you need to Google, the powerful tool of Google, to install the library. So for example, for this device, you just type in DHT 11 temperature humidity sensor and then the library language you want. So DHT 11 temperature humidity sensor, Python library. Which is what I use. But this is standard for any IoT library. I mean, pretty much this is the standard for the industry to make libraries for all the different languages that interfaces their sensors that they made. So all you have to do, I mean, they usually put on GitHub or their website, whatever the case is. In this case, if it was GitHub, you just clone the repository, go into the folder that you just cloned from GitHub, and you follow their easy instructions of just installing all their dependencies that they need. So for in this case, it told me to, upgrade my Python and then, run this little file called Python dev that would pretty much add on all the different Python extensions that would work with this little library for the sensor. But this is pretty much all the documentation would be on the website itself, and it should be very simple. And for Raspberry Pi, it would be the simplest because they know the community there is, it comes from it has a wide range of skill ranges. So once you would get the library, then you'd got to test your sensor. So in order to do that, you'd have to go into a text editor and make a program testing the sensor, see if it works, see if you got, didn't get cheaped out of your money. But the process would be import the library itself, tell it which sensor it is and what pin on the Raspberry Pi you're using. So in this case, I would use like a GPIO pin 3 and just let it know what sensor pin the Raspberry Pi is going to be connected to. And then just,
Are the numbers on the Raspberry Pi?
Yeah, so if you actually type in, Raspberry Pi GPIO pinout, you'll see pretty much all the different pins. I'll actually show you.
It shows in the schematic what the order is.
Yeah. So
0 to N.
Yeah, exactly. So if I go to the Raspberry Pi, I reference this all the time because this is impossible to remember. So if you have, this little, it's actually called pin 2 because it's the second GPIO pin. So, if you read this and let's say you want to connect it to, let's pick a random one, this one, GPIO pin 21, you just notice that this is 21, go to your code, and then tell it it's pin 22 on the Raspberry Pi.
Okay.
That's how it would know, where it is supposed to take readings in on the Raspberry Pi.
Got it.
Because the Raspberry Pi would not know otherwise. But then after that, you just, look at the website's documentation on their website, know how to use their specific library. And in this case, it's the website told me, or the company told me, to use their sensor by first storing their humidity and temperature sensor readings in a variable by calling this specific ADHT alpha Adafruit DHT read entry function call. And once it does that, then you could format the data in a certain way like this and print it out to the screen. If it works, if it is actually printing something, that's usually a good sign. And if it's not displaying like 1000 degrees Celsius, I think you're in good shape and you could trust that the electronic works and continue coding with the rest of your project. So luckily, the push button is actually much more simple. We're just going to be using the GPIO 0 library. So we don't have to really worry about this, but this is just for completeness. If you want to use any type of IoT sensor, it all follows the exact same process. It's never any different. It's not supposed to be different. It's an industry standard. So now we can move on finally to creating the actual application with Pubnub. And I made already, and this is all on GitHub, I made an application, using the GPIO 0 library and Pubnub and a Twitter API to connect those all together and make a tweet button. So with making Pubnub apps, it's actually incredibly simple. It's as simple as just importing the Pubnub library importing your specific IoT libraries, in this case, the GPIO0 library, configure the Pubnub with your specific subscriber key that you will receive when you make an account, a publish key, if you want to publish things when you're publishing account, and then, simple configuration. But all this documentation is on the website itself, very well documented. If you're ever confused, I promise you'll not have trouble learning all this. But this is how few lines of code you really need to start using, PubSub and IoT. So, if you want, you can make a little callback. And what a callback is, it's a function that every time you fire a message, on the Pubnub network, it'll right after call this little function, and then you can code it to do certain things. But we're not really interested in that today. We just want to make sure that when we tweet, we could check our Twitter and, tweet from a button. So the important things here to note is use the GPIO0 library to make a button. And this is actually the beautiful thing about GPIO0. But the GPIO0 library is that all you have to do to hook up a button is just type in button and then your GPIO pin number, like I said before, and save it to a variable. And the reason why you may not realize this is so special is because you don't have to worry about anything that a hardware electronics engineer would have to worry about, such as debouncing. And debouncing is, what that means is if you push a button, it's not actually pressing itself once. It's pressing itself about 20, 30, or 100 times in the span of milliseconds that you would never be able to tell. And this is because when you're pushing a button, it's going to be on a microscopic scale vibrating against the metal. And that's just going to be triggering the metal, the button, the sensor, about 100,000 times in a second. And you don't want that. You don't want, when you press a button, you're going to send 1,000 tweets. You do not want that to happen. And there are some clever ways in code to go around that, or in hardware, even more clever. And that's just not what we want to worry about. We just want to use this library. And that's just the beauty of IoT, is just there's plenty of resources out there like this. So once you've got that initialized, I have it connected to my third GPIO pin. You want to now make a tweet, format it. And I'll actually get to why we format it in this way and how you can learn how to format it. But just bear with me for now. This is all we're doing right here, is making a tweet, a custom tweet, storing to variable. So it'd be like, hello world, or whatever you want it to say. You'd format that into a JSON format, into message. And then when you want to make any program in IoT run continuously, just indefinitely, you want to make a while statement. This is called a while loop. And this is actually called polling in IoT. And that just means that it's going to be constantly checking your IoT sensors at whatever frequency the Raspberry Pi is set at. It's just going to keep running this code, keep going this while loop over and over again until your button is pressed. And that's what these if statements is. It has conditions. So if the button is pressed, you're going to let the terminal screen see that you pressed it. And then with the Pubnub Twitter API, you're going to publish to the Twitter API block. But for any message to publish actually over Pubnub, all you have to do is just call Pubnub, call the publish function, and then to whatever channel you want. And channels, all they are just, like TV channels. Different TV channels are broadcasting different pieces of data, just like in the real world with IoT is you'd pick different channels to publish different data. So let's say I have like a temperature humidity channel, and then I have a pressure channel from different sensors all around the world. You don't want them to conflict. We allocate them to different channels, and that's what we're doing here. So for our case, since it's just a button going to Twitter, we're just going to name it a Twitter input channel. And then you put in the message from here, the tweet message. And then if you want, you can make an asynchronous callback to whatever function we talked about earlier, but we didn't do that, so it's okay. And I add a little delay here just because if you add a delay here, it'll just make sure that the program's just not running too fast for our liking. But that is pretty much the simple, way you would code pretty much IoT things. The only things that would differ would be obviously your GPIO initializations and then what you do with whatever library you choose to use. But this is exactly how you do it for a push button and for many other simple cases like this.
Awesome. So that part where you're publishing to the Twitter input channel,
right,
that is a serverless function that's sitting in the clouds that you you put yourself in your Pubnub account. You can put the Pubnub Twitter block onto your account and associate it with this publish subscribe key and have it listen on that Twitter input channel. So every time a publish is made to that channel, the function gets all of your Twitter credentials from the Pubnub Vault, which is a safe place to store keys, API keys. It gets your special Twitter credentials and publishes to your Twitter account using the special Twitter app. So that looks like what Cameron's got pulled up here.
Yeah,
he knows exactly what I'm talking about.
Yeah, as Adam explained, we have the Pubnub Functions text header, and what this pretty much allows us to do, and this is the next step after you make your local program that runs on the Pi itself. You want to make it more IoT. You want to make it Internet of the thing. So with that, like Adam mentioned, you'd use a Pubnub function, which is basically anytime you can make it so that you can change its fire rate, but in this case, every time a message goes across your specific channel, you can execute a block of JavaScript code in the cloud to go along with that message. And this has numerous benefits in IoT. This means that you can code a lot of functions or a lot of logic in the cloud that takes care of all the heavy processing power that a really beefy IoT device would need. I actually wrote an article on Pubnub, on the Pubnub blog itself, saying the beauty of cloud state machines. And what that is basically explaining how in a cloud-based state machine model, you afford to make your IoT device really dumb and really cheap. And this is very valuable when you're on a mass scale. For example, smart farming. If you just want to make a bunch of sensors that control, a water valve, you want it just to be as simple as possible because you're trying to make profit margins, and you want to make sure the device only does what it needs to do. And then you could just send that data to the cloud, and the cloud would then process that data with your specific functions. So that just is, very useful, and Pubnub offers the best virtual tool for that. And for our case, that's exactly what we're doing. We made a push button, and all it is doing is getting a signal, a 1 or a 0 from the push button, and then sending that data to the cloud. That's all it is doing. And this function is going to handle all the different, specific things we need to do with that data, and make sure it connects to our Twitter and publishes a tweet. And we actually, like Adam mentioned before, we have a Twitter block that you could try out. It's super simple to use. I mean, all you have to do is just click try it now right here, and then it'll give you, a bunch of steps, and it'll actually give you the function to copy and paste into your own function, or create your own function to use for Twitter. And it's actually so simple. You don't have to do anything. I didn't write any of this. This was all Adam right here.
Yes. If you look on the left in your editor, you could see that there's a big stopped text with a little orange symbol. That means that the function is stopped. So I think that's why your tweet didn't go through earlier.
Oh, right.
So
okay.
to deploy to all of our data centers around the world, you can hit the Start Module button on the right. So this deploys this code on every data center that Pubnub has, and that ensures low latency for all of your publishes hitting your functions.
Yeah, correct. That's actually maybe why my tweet button didn't work. So what you do is, with any Pubnub function, is you code the function itself. And once you're done with that, you hit the Start Module, and that will deploy the module around the world to, again, like Adam said, all our data centers. And this will ensure the fastest data transmission travel, and this is how we guarantee quarter-of-a-second data delivery. But now this function is accessible across the world, in Eastern US, Western US, Asia, Central Europe, all these different places. And now we can hopefully see if this works. So I'm going to press the button, actually, and just hope to God it works. Press it a few times. And let's just check my Twitter to see if it worked. Okay, it's probably a syncing issue, but that's okay. But that's exactly how it would work in real life. It's probably honestly just my internet connection, but it's totally fine. But with this, it's super simple. You just copy this, and then with that, you can go to the Twitter website and just let them know. Just type in, Twitter. I mean, it's all on here. The Twitter blocks catalog. I'll tell you exactly what you do. You just, let Twitter know that you want to connect an external app to your Twitter account, and then with that, you can they'll give you a bunch of keys that you store in the My Secrets tab, and this is called the Pubnub Vault, and this basically ensures that all your secret keys, all your little confidential information that is specific to your Pubnub function, you can store them all here. So let's say, for example, you want to use your Twitter keys that they'll give you. Those are very sensitive and private keys. You'd store them here so no one could access them or whatever, and they're safe to use. So once you do all that, everything would be saved, and your function now runs globally around the world, and you don't have to worry about anything besides pressing the button, and in my case, making sure your internet connection on your phone hotspot also works.
And also, you got to make sure your keys are in the vault. It looks like your vault was empty.
Yeah, I actually think this is not the Twitter block I actually used for this project.
Okay.
It looks pretty empty and
a decoy.
Yeah, a decoy, a fake. Yeah. But yeah, let's see. And yeah, that is pretty much the essence of IoT device computing.
Great.
Yeah.
Awesome job, Cameron. We have a question in the live chat from Rakesh. He says, my Pi processor is heating up, suspecting power IC issue. Can it be replaced? I mean power IC.
The power IC on the Raspberry Pi is heating up, and he's hoping that he could replace it. Unfortunately, this is really difficult to do just because the Raspberry Pi uses through-hole pin technology to make their PCBs. And I mean, if it is a chip issue, just because the Raspberry Pi is mounted on a PCB board, it would be incredibly difficult to do that. But it is possible. It is totally possible. You just need a microscope, a really small microscope, and very precise tools to desolder that chip off the board, and then install a new one that you would hope they'd sell. I mean, they most likely would. I mean, it's made by Broadcom, so they probably would sell that chip somewhere.
So the more practical solution is just to buy a new Pi device, right?
Yeah, and the reason why I would recommend that 20 times or 20 million times out of 10 is because that is what IoT is all about. I mean, the do-it-yourself
frying your chips.
Yeah, I mean, frying your chips all the time is a totally normal process. I mean, when you have a smart farm, the reason why your smart farm would still work through the Internet of Things is because all your different devices are connected through the Internet, and your application should still work. And if one of those applications fail, your device is so cheap and replaceable that you could just pick and pull it out and use it. And that's why Raspberry Pi is so cheap. I mean, it's a computer in the size of a credit card. I mean, this couldn't even been imagined 40 years ago. So again, it would be very practical and actually intended for you to replace the Raspberry Pi. And they're not trying to make money on you by making cheap chips. They actually lose money on every single Raspberry Pi they sell to the individual hobbyist. But
they're really loving, giving company.
Exactly, yeah. And they're also just really meant for when people want to buy in bulk and stuff like that. They can profit off that and just overall the Raspberry Pi brand name itself. But again, if you want, you could totally look up some tutorials on YouTube on how to do that, or just anywhere. But I would not recommend that because you could actually, in my case, do what's better, desolder all the other things off the Raspberry Pi, like the USB ports and the SD card reader and all those things that are more valuable and actually easily able to solder off, and save those for another project. But don't try and destroy your entire Raspberry Pi by trying to use this chip.
Okay, let's see if we have some more. Well, I have some questions.
Sure.
Why would I use Pubnub when I could use MQTT to send data with my IoT devices?
Right. So if you're a student or a recent graduate from, electrical engineering, computer engineering, even computer science, maybe, you have been taught to use MQTT for things like this. The problem with MQTT is you don't get the benefits of cloud computing, which has all the benefits I mentioned earlier, which is making your device dumber, cheaper. And
So
just
you get Pubnub Functions with Pubnub, which you don't get with MQTT.
You do not get that with MQTT. MQTT just gives you PubSub, and although it's free, its value, it does not even compare with the ability to save yourself hundreds to thousands to even millions of dollars on just investing in dumber, cheaper devices that could, be not used otherwise on MQTT, which would need a more capable machine to run MQTT itself in open sockets. So that has its pros and cons there. But
right. So Pubnub has all of the APIs that MQTT does not. Like you can have history of channels to get messages that were sent and get a specific time token of when they were sent. Also, you get presence to see who is online in the channel, who has the socket connection open. Things like that are benefit that MQTT does not provide. And for hobbyists, Pubnub is very cheap. Unless you're sending over 1 million messages every month, it is totally free if you're spending less than that every month. So let's see. Got some more questions for you. How could I get this project working if my device doesn't have an internet connection out of the box?
Oh, okay, that's a good question. So let's say you're using Arduino, right? It does not come with the wonderful capability of Wi-Fi that the Raspberry Pi 3 comes with. That's why we chose it for this project, to make it much more simple. There are plenty of different IoT extensions that will provide any piece of hardware with internet connection. And that's, again, remember what I said before, when IoT is just really cascading different systems of electronics together in the fashion of internet. You can actually install what's called an ESP8266 Wi-Fi module chip, and it's just another cascade to the system. This is what it looks like. It's incredibly cheap. I mean, it says $6 here, but I found it for $2 online. And basically, you'd wire up the pins in a certain way to your Arduino, and you would hook it up in that way, exactly the way the website would tell you, or any YouTube tutorial would tell you, or online tutorial. And now you would have Wi-Fi. And that's the whole beauty of making things smart, is that you just figure out ways to make your system more capable. So if you want to add Wi-Fi, you add a Wi-Fi chip. You want to add other capabilities, you add those other capabilities. It's the whole idea and beauty of IoT.
Yeah, so all these little parts are modularized, so I can grab exactly what I need and get the array of the exact parts for my project. Like if I need internet access, I could get one of these guys. But with a Raspberry Pi, it looks like this is already integrated. Is that right?
Yeah. So the Raspberry Pi, they learned from their community that they really wanted internet on their microcontrollers. So the Raspberry Pi 2 didn't have a Wi-Fi chip on it. You actually had to have it connected to your computer or a Wi-Fi module to get Wi-Fi on it. But the Raspberry Pi 3 edition comes with the Wi-Fi chip, and it still maintains to be very cheap for what it does. And now it could be a full functioning computer, or a laptop if you want to add a battery to it. But again, and these Wi-Fi module chips are incredibly cheap, and they're very replaceable. I mean, they are cheap. They do break down if you are not very careful with them. Very unforgiving. I've gone through about 10 in my life just because I just did not take the time to be careful with the voltages you send through them. But they're cheap for a reason, so you could just order 10 of them and mess up as much as you want, like I did.
Right, and if you don't mess up, then you don't learn.
Exactly.
So would you say that IoT is an expensive hobby?
I mean, it could be, but it also doesn't have to be. I mean, if you want to use MQTT, it could be a very expensive hobby. But, as a hobby enthusiast and a professional specialist, IoT is accessible to pretty much anyone. It's just the sky is the limit, and the ground is, impenetrable. So, like, let's say, for example, you want to build a very professional build system. And you want to be very smart about it, you can figure out exactly, draw the circuit by hand or Google the circuit and figure out how dumb can I make this device? How cheap can I make it? How what is the most amount of hardware specification I can get with the least amount of money. And this is what, companies do for a living. This is what electrical engineers do for a living. They pretty much, go to the pen and paper and figure out exactly where they cut corners. If this Wi-Fi chip offers, let's say 30, this is just for example of how specific you can get. But for this Wi-Fi chip, you didn't want this specific frequency of Wi-Fi, of internet, let's say, you can buy a cheaper device that, has a slower processor that will tune to a very slow frequency. And then you could send data another way and make it cheaper that way. But even for the hobby enthusiasts, you could just buy a Raspberry Pi and you'd be good to go. And you could buy pretty much any, device. You go to adafruit.com and, you can buy pretty much any sensor you want that could do incredible things, and it'll be very, very cheap. So it load. I guess my Wi-Fi is just super slow, but yeah, you could just, it's accessible to anyone. The more dedicated, specialized your hardware gets, the cheaper it gets. So the better you become a hardware hobby IoT enthusiast, the cheaper your products will be.
Awesome. So can you tell us what some real world applications are for having IoT devices hooked up to Pubnub, so you have Pubnub Functions able to kind of do some processing for you? Can you touch on that?
Yeah, is the question pretty much how you'd implement, how,
what are some real world scenarios that some customers are using?
I wrote an article on the Pubnub blog that explains this, the beauty of IoT in the real world. Like I mentioned before, smart farming is one of the biggest investors in IoT right now. When you have large-scale mass crops, you want to pretty much control every milliliter of that crop, so you're not wasting any resources. But IoT pretty much is in every part of the world, and in the future, it'll probably be every part of the world. You put smart in front of anything, and now it is IoT. Smart lamp, smart desk. You can make anything IoT. You can make a smart desk, or smart mirror. It's been done so many times before. And it's just becoming easier and easier to do. So, IoT benefits the everyday consumer. It also benefits, the real world. It benefits people in Africa who are starving. And there are companies out there right now implementing IoT to make smart farms and agricultural farms to make farming very cheap for those people in that part of the world.
Looks like we got another question in the chat. William says, is there advantages to using a master RPi to slave Arduino rather than using the Wi-Fi chip?
Yeah, it would be more complicated, but
you recommend using a Wi-Fi chip instead?
Yeah, I would recommend using a Wi-Fi chip just because, again, if you're using a master-slave model here, you need, both the Arduino and Raspberry Pi itself that doesn't have the capability. But again, if you could figure out how to do that, that would be fine. If you have those parts laying around, that would be beneficial. But again, the Wi-Fi chip itself is very cheaply integrated into the Raspberry Pi. You saw this little ESP8266 cost, a certain amount of money. It only costs, it costs about $2 for the consumer device. So just imagine how much it costs for the company to integrate.
Oh, right. Someone buying it in bulk, it's much cheaper. I see.
Yeah. So Raspberry Pi, it's pretty much adding nothing to the cost. I would recommend you buy a cheaper device that has Wi-Fi capability. If money is the issue. But again, if you have the resources and you want to make a master-slave connection, you have to keep in mind those are not optimized to do that certain task. You have basically modified the system to do that, but you did not optimize the system to do that. But that would be really cool and fun to do. And I actually made a master-slave Raspberry Pi Arduino combination last semester for one of my projects, where I basically made a Pokemon type simulation where you could trade Pokemons together. But Yeah.
Ooh, can you explain that a little bit? That sounds cool.
Yeah, so basically, use two different devices. So I used a Raspberry Pi, I didn't use an Arduino. I actually used an mbed processor, and I pretty much, used the Raspberry Pi as a master, and the what's it called, the mbed as the slave, and I pretty much ran a simulation of Pokemon on it, connected to a Game Boy, and through that, I was able to then connect or trade the Pokemons over like the the connection wire or whatever, the bus for the data.
Oh,
Yeah,
cool project.
yeah. It was pretty cool.
Great. Well, oh, we got one more question from Sunil. He says, any thoughts on security part of IoT devices, or is this only limited to hack?
So, okay, so that question actually could be expanded very broadly, but I think I know exactly what you're asking. So, uh, okay, so I guess the question and the way I'm interpreting it, if you want to specify in the in the chat, please feel free to. But what I understand is that where does, I guess, security fall into the play of IoT? And when you're hacking things, I guess, do you mean that could that jeopardize different sorts of security, or I guess are there security measures you need to take? I'll answer all those questions, but again, if I don't answer your question, feel free to specify in the chat below. But basically, security is a huge issue when it comes to IoT. I mean, you take smart locks, for example. That is one of the biggest security risks imaginable for banks or company buildings. The way it works is basically you have a NFC chip, which is in your iPhone for tap to pay, and basically you'd go to the lock, and it contains a bunch of like it activates basically a key number in bits of ones and zeros, and the keypad would then read it, and if it's the correct bit number, it would let you in and unlock the lock. But the security thing with IoT is that since data travels over the internet, it is very vulnerable. Probably the most vulnerable medium, just because anyone can connect to it from anywhere in the world. And that is where encryption needs to take place. So there are various security measures for this. I mean, like, for example, for the keypad lock, all it takes for someone to steal your keypad card is if they tuned into the exact frequency that your NFC chip is, tuned to, and they can actually steal, they could read the NFC card and figure out exactly what combination you have, and they could save it to their own, makeshift card and then go into your building. I mean, I think Vox or Wired on YouTube actually showed a video on exactly how to do this, but it's a huge security risk, and there are definitely security measures when you work with IoT. So if you're working with sensitive projects, there is a workaround, especially with Pubnub. If you, just make sure your IoT device is just transmitting very, just data, the data that doesn't really mean much. It's just a bunch of ones and zeros. If you push that to the cloud in Pubnub and then process it there, Pubnub guarantees with our encryption, your data is secure and safe. So you don't have to worry about, let's say, I make a little keypad and it says like 4, 5, 6, 7 is my password. All I'm gonna send out to the internet is 1, 0, blah, 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 but I'm gonna mask it in a bunch of just random data. So no one's gonna know what it is, but then I'm gonna process that data in the cloud, and that data will be then secured with our encryption services.
Right. So when you're making your Pubnub connection, you can set a flag in the configuration. All of our SDKs have this option. It's a SSL option, so you can have a secure SSL connection. And additionally, you can also add your own encryption. So you can encrypt your messages before they're sent over Pubnub. So you could have double encryption. You can even do triple and quadruple if you really want to. But as far as your Twitter application, that is also secure because all of your API keys are stored in the vault, which is a secure place to keep them. And as long as you don't have anyone malicious near your IoT who's going to push that button when you don't want them to push that button, your app is going to be secure. So this app can be used for more than just a hack.
Yep. Sweet. Oh, and just a side note, don't encrypt it too much because then the government will come after you. There are some like regulations to how much you could encrypt, which is crazy. But yeah, I mean, that goes a long way. But thought I'd
Yeah.
say that.
So Sunil said thank you in the chat. So I guess we answered his question well.
Okay, sweet. Right on. Thank you.
Great. So it looks like we don't have any more questions. I guess that means we're done here. Thanks so much for taking the time to show us how to do this, Cameron.
Of course,
Appreciate
my
it a lot.
pleasure. And thanks for letting me come out and speak and talk about IoT.
Great. I'm going to end the streaming right now.
Sure. Goodbye.
Bye-bye. Thanks, everybody. Oh, there's Cameron.
Yo.
Hey, Cameron.